Now let's see how we use enthalpy change of combustion that we have calculated to find any delta H of any reaction. So reactants changing to products, so we need to find the delta H here. Now these reactants can be burned to produce the products of combustion, and the products can also be burned to produce products of combustion, so carbon dioxide and water. So reactants can be changed to carbon dioxide and water, products can be changed to carbon dioxide and water. Now enthalpy of combustion of reactants, so that's this arrow here, and enthalpy change of combustion of products is this arrow. Now if we find delta H in terms of delta HC, so we would start here at the tail, so going in this direction, and then we would go up in this direction. So delta H is hence enthalpy of combustion of reactants here in the same direction, and here we are going in the reverse direction, so it would be minus enthalpy of combustion of products. Now because you can have more than one reactant and you can have more than one product, we're going to use sum. Now let's see how we apply this. So calculate the enthalpy of formation of methane given the enthalpy change of combustion values. So methane, formation of methane is, so methane is CH4, you're making this from carbon and hydrogen. So this is equation for formation of methane. And so these are the reactants, these are the product. You have the enthalpy of combustion of the reactants and enthalpy of combustion of the products. So delta H of this reaction is enthalpy of reactants, so the sum of enthalpy of reactants minus the sum of enthalpy of products. You will see that I always write these because it can be very easy to make mistakes in these questions because of the signs involved. So I always write these so that I can check my answer after I've done the question. So carbon, I know it's minus 394 plus 2 times minus 286. When you write it this way, you're minimizing the risk of you making mistakes because you know that you're multiplying with the correct stoichiometric ratio in the question and that you would be able to process the signs carefully. So you should get minus 80 kilojoules per mole if you do it properly. Okay, so then you have another question. I'm going to leave this one up for you to try. Just a summary of the equations that we've seen. So these are the equations that you need to remember. So delta H in general is delta H of products minus delta H of reactants. This is in general. And the second equation, delta H of any reaction is delta HF of products minus delta HF of reactants. Not forgetting that you have to add them up if there is more than one, and that you need to take into consideration stoichiometric ratios. Now delta H in terms of enthalpy of combustion, so it's sum of enthalpy of combustion of reactants minus sum of delta HC of products. You need to remember these equations because you can be required to use any of these, whether in MCQs or structured questions.